problem 49, chapter 14, and Giancoli 6th edition. First question is, find the total power radiated into space by the sun, assuming it to be a perfect emitter. When they say perfect emitter, what it means is that emissivity is equal to 1. Okay, so this is an important piece of information that came just with words. Perfect emitter means emissivity equals to 1. The sun, we are assuming that it has this temperature of 5500 Kelvin, and they also give us the radius of the sun. All right. With this information, we want to know the total power. Well, so the sun emits by radiation, so the total power, I'm going to use the equation that we discussed for radiation, is this one. It depends on the emissivity. It depends on the Stefan-Boltzmann constant, so go to your book, area, and the temperature to the fourth. The area here, we're assuming that the sun is like a perfect sphere. So the area for the sphere, okay, it's not the circle, but a sphere, is 4 pi r squared. And remember, the temperature has to be in Kelvin. They already gave us in Kelvin, so we are fine. So you just need to use this equation to find the power, right? Because we'll have joules per second, this heat per second, Q per T is power. All right, so we are done with question A. Question B is, from this, determine the power per unit area. Okay, so now they want the power per unit area, but which area? Per unit area arriving at Earth. Okay, so here we have the sun, and it's emitting all over, all around it. Okay, and it will eventually hit Earth, which is down here. Okay? So this whole big sphere here is the sphere of the power that the sun is emitting, which is hitting Earth. We want to know what is this power per unit area. All right, so what we have to do is that value that we got above, okay, so this power that we got here, we are going to divide it now by this area, but which area? The area that goes from the sun all the way to Earth. Okay, so this is going to be 4 pi, but careful, this r squared here is the distance between the sun and Earth. Okay, and this value is also given to you. Okay, so this is now a much bigger sphere than the size of Earth, and than the size of the sun, and that's it.